Welcome, everybody, to math class. Today in math class, we will be starting Unit 3, Introduction to Polynomials. Polynomials. So, new unit for everybody. So today's going to be kind of one of those days where it's exactly what it says it is. It's an introduction to polynomials. So we're going to learn how to name them. We're going to learn what's a polynomial, what's a monomial, what degree is the polynomial, how do I start and end the graph when we're talking about polynomials. So lots of terminology today. Lecture's a little bit long because of the amount of terminology that's in there. Plus, I'm long-winded all the time anyways, so it makes it even worse. But it is what it is, completely different from what we've been doing. So really kind of could be a fresh start for some of you. It's not that cold. It's like 55 degrees outside. But it's cold in here. Oh, the sun went away. Anyway, not to make it any longer. So, lots of notes today. Not a lot of things. You don't need to write everything. And that's kind of the key to everything. I'm going to highlight things that you should write. And then we'll call it good. So, first and foremost, polynomials are made up of a couple of what we call monomials. So we've talked, all of these terms you've heard me saying all year long. Okay, you've heard me say polynomial. You've heard me say monomial. You've heard me say these different types of things. So it's not new terminology. We're just going to put some definitions to them now. So monomial is an expression of something that's in the form ax to the n. The a is just a number. The x is just a variable. The n is just an exponent. That's all they are. So down there are different examples of monomials. Write one or two of them, call it good. 5x to the 7th. Our a value is 5, our variable is 7, our variable is x, our exponent is 7. It's considered to be a monomial. Mono means one term. It's one continuous term made up of a real part, a variable, and an exponent. Now, it doesn't have to be. It can just be a number, 5. Technically speaking, 5 is 5x to the 0, but whatever. Can be a string of them. But again, if they all kind of go together side by side, which indicates multiplication, it's considered to be a monomial. When you string monomials together, or just a monomial in general, it's what we call a polynomial. The polynomial is a monomial or the sum of monomials. So it's the sum of individual terms. Okay? Each of those pieces within a polynomial is considered to be a term. So something like negative 9x squared plus 5. That's a polynomial. It's a monomial plus another monomial. A monomial is also considered to be a polynomial. Whatever. And the other two as well. Now, obviously, addition and subtraction, it says it's a monomial or the sum of monomials. Subtraction is just adding the opposite. So subtraction is the same thing as adding, it's just adding the opposite. Okay, so whatever. So, and we've talked about quadratics. We've talked about trinomials. We've talked about all of these things. Quadratics was the whole last chapter. And quadratic is an example of a polynomial. So that's kind of the basis of where we're going then today. Within that then, we want to be able to do several different things with the polynomials. So the first thing I want you to do is I just want you to write that down. Just write 2x plus 5 minus 7x squared minus x cubed plus 4x to the 4th. Okay, so it's a polynomial. It's the sum of several monomials. So we considered it to be a polynomial. Now we want to be able to do several things with these. And the words are important, the definitions, they'll make sense. So standard form. So just write down the word standard form. Don't put anything else, just put standard form. Essentially what standard form is standard forms are the terms arranged in order from the largest exponent to the smallest exponent. We've done standard form in here a ton already. Can't tell you how many times I said ax squared plus bx plus c equals 0. Told you that was standard form in the last chapter. I think I wrote it down every single day for the last 3 weeks. Why is it standard form? It's standard form because it goes from the largest exponent to the smallest exponent. And that's standard form. So if we take this 2x, negative 2x to the, and so on and so forth, if we put it in standard form for this is going to be finding your largest exponent, which is x to the 4th, putting that first. So standard form is going to be 4x to the 4th. Now we look to see if there's an x to the 3rd. There is. So we're going to bring the sign along with it. So it's minus x to the 3rd. Now we look for x squared. So negative 7x squared. Now we've got a negative 2x. So we're going to put negative 2x. And then plus 5 at the end. So our exponents go 4, 3, 2, 1, none. To be in standard form, does it have to go 4, 3, 2, 1, none? No. Does it have to go 6, 5, 4, 3, 2, 1? No. Could it go 6, 2, none? Yes. As long as you're from the largest exponent to the smallest exponent, then it's in standard form. Again, understanding that that last piece, that 5, we'll talk about it in a minute. So that's standard form. The next thing for your notes is degree. Degree is the highest exponent of your polynomial. So it's the highest exponent of the polynomial. So if you've already got it in standard form, finding its degree is quite easy. In our case, the degree of this is 4. Okay, there's our degree. So the degree in this, we just say it's a 4th degree. For now, we'll give it a name in a minute. Okay, but the degree of it is 4th. It's the largest exponent. When it's written in, it doesn't need to be written in standard form to find the degree, but it helps. Leading coefficient is the next term. Leading coefficient is the coefficient of the first term in standard form. Well, that means you need to know what coefficient means. Coefficient is just a mathematical way of saying number. Leading is first. So it's the first number that you see when it's in standard form. And it has to be in standard form in order to find the leading coefficient. Okay. So in our case, the first number that we see is 4 as well. Just happens to be 4. So our leading coefficient in this is 4. So it's a 4th degree with a leading coefficient of 4. Basketball game? Wrestling meet? Good luck. Number of terms. Good luck. Number of terms. I think that's pretty self-explanatory. Number of terms is the number of terms that your polynomial has. Each individual part is considered to be a term. So the number of terms, all you have to do is count your terms. 1, 2, 3, 4, 5. It's got 5 terms. So the number of terms this one has is 5. Yes, there's one. It should be in my top left-hand drawer of my desk. Okay. So any questions with those terms or the definitions of those terms? Because the vast majority of today is what we're going to be is we're going to be doing these things. Okay, so when we name polynomials, we don't just want to say it's fourth degree, it's fifth degree. We want to put names to them. So when we name polynomials in two ways. The first table is naming them by degrees. The second one is naming them by the number of terms. So the green and tan one talks about, okay, if we know the degree of it, which we just learned how to do, how do we name it? If it's a constant, okay, an example of a constant would be something like 5. Okay, if it's 0 degrees, which would be something like 5, we call it a constant. If it has a degree of 1, meaning it's like x, we consider that to be linear. If it's second degree, which would be x squared, that's quadratic. We did quadratics the whole last chapter. That's what it was on. Okay. Third degree means it's cubic. So like x cubed. X cubed. Not like, just x cubed. X cubed is cubic. Fourth degree is quartic. How do you remember something's quartic? A quarter? Quartic, a quarter? Quarter's a quarter of a dollar, a fourth of a dollar. Quarter's a fourth of something. Just put it in. Oh, here, no, I'll take it. And then if it's fifth degree, x to the fifth, it's quintic. I don't know, I remember quartic because it's a quarter. Quintic, it's just the next one. I don't know, whatever. Okay. So that's by the degree. And by the degree, it's only the first term if it's in standard form. We don't care about anything else. Then we also can have to name it by the number of terms. If it has one term, it's considered to be a monomial. So x, 2x, that's one term. That's considered to be a monomial. Binomial, again, term you heard 876 times in the last chapter, now 878 times. A binomial, if it has two terms. Bi means two, so something like x plus 1 is considered to be a binomial. Trinomial, same thing. We heard that term, you've heard that term forever, or at least 802 times. If it has three terms, it's considered to be a trinomial, and then after that, we just get lazy. Anything after three terms, we just say it's that number of terms. Why we don't do it with all of them, I don't know, because people like to put names to things. If it has four terms, it's a four-term polynomial. If it has five terms, it's a five-term polynomial. Kind of the same thing goes with the degrees. If it's a sixth degree, we just say it's sixth degree. If it's seventh degree, we say it's seventh degree, so on and so forth. Okay. So let's look at just two examples. You don't need to write the whole thing down because the whole thing, well, I guess you can if you want to, but whatever. If I have 5x cubed minus 3x plus 5, first thing I do is check that it's in standard form. It's in standard form. Now, if we're just going to name it, the degree is 3. So its degree is 3. What's the name of something that's third degree? Cubic. So we say it's cubic, and then it has three terms, so it's a cubic trinomial. And that's all you have to put if you're asked to name it. It's a cubic trinomial. For the second one, negative 3a to the fifth plus a cubed plus 2a squared minus 3a plus 5. Well, degree, it's fifth. Fifth is quintic. So we would say this is quintic with 5 terms. Good enough for me. Always name it by its degree first, and then its number of sides. Quintic fifth term polynomial? No, just put quintic with 5 terms. All right, so now let's put all of those together in a couple of examples. So our first example, we've got 3 minus 5x squared plus 4x. She knows. So the first thing tells us to write it in standard form. So by standard form, we look at the largest exponent, which is 2. And we bring the coefficient along with it. So it's negative 5x squared plus 4x plus 3. That's standard form. Goes from the largest exponent to the smallest exponent. We identify the leading coefficient. The leading coefficient is the number out in front of our first variable in standard form. So our leading coefficient here is negative 5. Degree, it's the degree of your largest exponent. So it's 2, or second degree, I guess. Identify the number of terms. 1, 2, 3. Woohoo, I can count to 3. Got 3 terms. And then we name it. So second degree is quadratic. 3 terms is a trinomial. And there are our answers. Okay. And that's really the first part of what you're going to have to be able to do today. There's one more part to it we'll get in just a second. But are there any questions on this one? All right, try that one. Do those 5 things for that polynomial. Go, gadget, go. Did anybody get to see the bug-smelling dog today? It's a cute little dog. Nobody got to see it? Poor things. Nobody's seen the picture of it? They had a bed bug sniffing dog come through our building today. It's a cute little dog. Rewrite it. What comes first? 8x to the 4th plus 3x squared minus 4. Leading number. Degree. 4th. Number of terms. 3. So it's a quartic. Quartic trinomial. Good? Okay, so those are the first 5 things that we have to do. This next part that we have to be able to do is we have to be able to do what we call the end behaviors. So for your notes, put end behavior and don't put anything else. Okay, and you're going to need some space for this one. So the end behavior of a function is a description of what would happen to the graph if you extend it both left and right. So it's essentially what happens at the start and the end, but we don't say graphs have starts and graphs have ends. They just happen. Okay, so we call it end behavior. So the end behavior for this one, we kind of look at those arrows. That's what it's happening at the ends of it. Okay.
Web results. I can show them if you ask again from your iPhone.
Okay, I'll ask my iPhone. Or I won't. The end behaviors for the second one are there and there. Okay. Now there's specific end behaviors that happen for specific situations, and here they are. Okay, first and foremost, reminder about the quadrant system. This is my x-axis. This is my y-axis. The upper right is quadrant 1. Upper left is quadrant 2. Lower left is quadrant 3. And lower right is quadrant 4. That's how the quadrants are named. So when you hear me say 1 and 3, which you're going to hear me say in a minute or two, that's what I mean. That's how our quadrant system works. So when we're dealing with end behaviors, we're worried about 2 things. We're worried about the degree, and we're worried about the leading coefficient being positive or negative. Those are the only 2 things we're worried about. The degree and the leading coefficient's positivity or negativity, however you want to say that. So, if we're talking about the degree, let's say that the degree is odd. So, you're given a polynomial and the degree of that polynomial is odd. That means that it's like a 1st degree, 3rd degree, 5th degree, 7th degree, so on and so forth. But its degree is odd. And the leading coefficient, it's too big of a word to write down, but so we'll put LC for leading coefficient, and that leading coefficient is positive. This is what the end behaviors are going to do. If it's odd and positive, your end behaviors are going to be in the 1st and the 3rd quadrant. This needs to be in your notes. If it's odd and the leading coefficient is positive, then draw that graph. Your end behaviors are going to be out of the 1st and the 3rd quadrant. So if you think of something like x, x is a 1st degree polynomial. I'll put a 3 out in front of it. So if I have something like 3x, 3x is a line. 3x is a line that goes like this. It goes out of the 1st and the 3rd quadrant. And that's how lines always do. Lines' end behaviors are always out of the 1st, and unless it's but otherwise we're sitting at 1st and 3rd quadrant. If the degree is odd, so the other way this could be, if the degree is odd, 1, 3, 5, 7, and so on, and the leading coefficient is negative. So it's odd for the degree and the leading coefficient is negative. Then it has that downward slope. So the end behaviors of this are in quadrants 2 and 4. Okay, so it's that negative slope thing. It's going downhill. Okay, it doesn't matter if it's a third degree, a cubic, fifth degree, a seventh degree, whatever. That's where their end behaviors are going to be. So we've got if it's odd and positive or negative. Well, the only other choices then are, okay, what happens if the degree is even? So 2, 4, 6, 8, and so on. Leading coefficient is positive. So if the degree is even and it's positive, then your end behaviors are in 1 and 2. It's that parabola that we talked about so much last chapter. Parabolas look like this. When our A value was positive, it went uphill. So 4x squared looks like this, looks like a U. And that's always going to be the case if the degree is even. If the degree is even, two, 4, 6, 8, and the leading coefficient is negative, then our end behaviors are in 3 and 4. So something like negative 4x squared. We said what happens when that A value is negative? It flipped. It goes downhill. Right? It had a maximum point, had a maximum height. So that's the other thing we want to be able to do with these. We not only want to be able to name them and do all those other things, but we also want to be able to tell what the end behavior is for these. And when you're doing the end behaviors, your answers are these parts right here that I have highlighted. That's what your answers are going to look like. It's just the drawing of them. All right, so let's look at an example of something that you're going to have to look at. So if I have something like 3x to the third minus 4x plus 2, and it says describe the end behaviors. If all it says is describe the end behaviors, I only care about the leading coefficient. Nothing else matters to me. So the first thing I ask is the degree even or odd? Well, what's the degree of it? 3 is the degree. Is 3 an even number or an odd number? It's odd. So it's odd. My leading coefficient is the number 3, right? Is that positive or negative? Now, 3 is a positive number, I think. So it's odd and positive. So odd and positive means I go to there and there. That's your answer right there. That's what you're expected to do in my room when you're asked what the end behaviors are. You don't have to put it in the first and third quadrant. You simply put arrows in the first and third quadrant, because eventually we're going to graph these things. And when we graph these things, now we know where they start and stop, so to say. Okay. Second one, negative 4x plus 2. I only care about the negative 4x. What is the degree of this one? 1. 1 is odd. The leading coefficient is negative 4, and so that makes it negative, right? So it's odd, degree, and negative. So that's 2 and 4. So odd and negative is 2 and 4. The next one's negative 5x to the 12th plus a whole bunch of other stuff that I don't care about right now. Degree is 12, so that's even. Leading coefficient is negative 5, so it's even and negative. Even and negative is 3 and 4. And the last one, 3x squared. Degree is 2, which is even. 3 is a positive number. Even and positive is 1 and 2. Keep those notes handy today. You're going to need them as you go through things. So on your assignment today, then, you're going to kind of be expected to put them all together. Okay, I'm not going to do one. Essentially, what your homework's going to do today is it's going to go back to like these problems back here. It'll be just like this. And then the last question would be, what's the end behavior? So in this case, it's even and positive, 1 and 2. Make sense? Okay, the assignment is sitting in Schoology now. It took me a while to put it in there today. The first hour, last hour, didn't have it put in there until like the end of the hour because they didn't tell me it wasn't there. But it's there now. So you should be able to work on it. Should be able to get it done before you walk out of here today. You got 20 minutes. Get it done.